All right, everyone. So for today, we're going to start out with a vocab word, which this idea of equivalent ratios. So we spent all day taking a look at mixtures, doubling them, tripling them. What we were really creating were two ratios, A to B and C to D, that are equivalent. What makes them equivalent is this idea of S right here. You need to find some common scale factor um, that you're going to multiply each of them by to change that number. And if that scale factor can be the same in both situations, then you know those two ratios are going to be equivalent. And again, equivalent is just a fancy way of saying equal. All right, so if I have a recipe for fizzy juice that says mix 5 cups of cranberry juice with 2 cups of soda water, I'm going to take a look at section A. To double this recipe, we would use 10 cups of cranberry juice with blank cups of soda water. So I'm starting with this idea that I had 5, but now I got to 10. I need to think of something I can multiply to get me from 5 to 10. Well, I multiply that by 2. It's a times 2. Which means if I take 2 times 2, I know it's 4 cups of soda water. All right, in this next one, we're going to now triple this recipe. Now I'm at 15. Well, how did I get from 5 to 15? Well, it said triple, so times 3. If I take my 2 cups then and do 2 times 3, I'm going to know it's 6 cups of soda water. All right, so we're going to take a look at this diagram. It's kind of cool how this is put together. This diagram shows a single batch, a double batch, and a triple batch. So we can say that 5 to 2, that's this guy, 10 to 4, and 15 to 6 are equivalent ratios. Okay, even though the amounts of each ingredient within a single, double, or triple batch are not the same, they would make fizzy juice that taste the same. Which we kind of tried with our little lemonade experiment today in class. So if the equivalent ratio stays the same, then we know that the taste is going to stay the same. We can make different amounts. We can make a small single batch, a large triple batch. We can make something that's even 10 batches worth. But as long as we're using the same ratio, the taste will stay the same. All right, so we're going to look at example 2. You're trying to figure out what recipe is the sweetest lemonade recipe. Here are the labels. So you have old-fashioned lemonade and Little Susie's lemonade. So what I'm concerned about is the amount that's in there and how much sugar. 17 grams, okay? So for this one, it creates a ratio of 8 ounces total to 17 grams of sugar. This one creates a ratio of 6 fluid ounces total to 14 grams of sugar. 6 ounces to 14 grams of sugar. So if we take a look at these two ratios, I should probably put amount, sugar, amount, sugar. Which one do we think is going to taste sweeter? Well, it's kind of hard to compare these two right now because the amounts are different. This one only represents 8 ounces. This only represents 6 ounces. So I want to find an equivalent ratio that's going to help me compare these a little bit better. So can we think of a number that both 6 and 8 can be multiplied to? Looking for maybe a least common multiple. I would think that's 24. So what if I make this 24 ounces? How did I get 8 to 24? Well, I multiplied by 3. So I'm then going to take my 17 and multiply it by 3. That means my sugar is then 51 grams. I'm going to do the same thing. What do I have to do to make 6 24? I have to multiply by 4. If I do that to my 14, I can see that's 56 grams. Okay, so just to kind of clarify, let's make the pink over here, that's the sugar amount. And the 24, this was my amount in the whole little packet or in the cup that you got. So I can see we had two ratios that were different and it was hard to compare them. So we used equivalent ratios to make the amounts the same of the total bottle so that we can get a better look at the comparison for sugar. It looks like Little Susie's over here has more sugar, so we can say Little Susie's lemonade had more sugar in the same amount, so it is sweeter. All right, everybody, that's all for tonight.